So just to let everybody know, we'll start in about another minute or so to just give people time to get online. And so about 2 minutes, we'll start. And we are recording this so we can post it online, just so everybody knows.
Is that the theme music? Is that coming from you guys, Dave? And yeah, okay.
Text saying that the password is not working for a majority of the people.
Oh.
Is that for the people that where you sent it out this morning, you mean, to the folks on campus?
I don't know. I got one from Fresno State. I don't think they're on our list.
Well,
Can you tell them just to click on the link? Shouldn't need the password if you click on the link.
I think I still had to enter the password when I clicked on the link.
it depends on probably when.
Oh, maybe if it's in if you're within the group or not, maybe.
Oh, it may have gone from my Gmail or something. Yeah.
Yeah, they're saying the password on Facebook is incorrect.
What is the password on Facebook? Can you quickly check, Karen? I can check too.
Is the password? Can you ask them what the password is, Kaan?
It's missing the 2 at the end. Password is 867092.
Ooh.
It's
Okay.
missing the 2 at the end.
Oh, did it clip the?
All right, let's put it on Facebook right now. I'm going to put it on Facebook right now, and we'll start. All right. Now it should be okay on Facebook. Okay, I think we'll get started. Hopefully we'll have a few more people join. Sorry about that issue with the password on Facebook. It should be okay now. So my name is Dave Block. My co-host is Anita Oberholster. She's there in another window. At least on my computer, she's off that way. And we have a really interesting topic today for office hours with Dave and Anita, and that's the area of vineyard automation and vineyard mechanization. We have 2 speakers that are joining us today from the department. The first speaker is our newest faculty member, Professor Mason Earles. Mason joins us after a PhD in basically in plant physiology at UC Davis and a postdoc at Yale. After which even though he was working on things related to plant physiology, he got very interested in artificial intelligence and machine learning, deep learning. So much so that after his postdoc, he was hired by Apple to actually do just that. He was with Apple for a couple of years and then joined us just in the fall. His area of research is in, well, he'll talk about his area of research, but in the area of vineyard automation and data processing, working with large scale data. Our second speaker is Kaan Kurtural, who's our cooperative extension specialist in viticulture based at our Oakville station. And Kaan has been with us for 5 years as an extension specialist. Prior to that, he taught at Fresno State in viticulture there. His work has spanned quite a few different areas of all related to key problems that we have in the wine industry here in California and around the world. He's worked on disease pressures and understanding things like red blotch. He's worked on clonal trials, looking at, for instance, different clones of rootstock. But perhaps most importantly, especially for this discussion, is his work on vineyard mechanization. And he has even established what he calls a no-touch vineyard at Oakville Station. And he's going to be talking about that and other things today. So what we'll do is we'll have both of them give a brief overview of their research. And if you have questions along the way, you can ask them by electronically raising your hand in the participants panel, or by sending them to us in chat, and we can read them, whatever you'd like to do. Again, after the statements, their opening kind of introductions to their research, we'll just open it up for discussion. So with that, I think I'll turn it over to Mason to start us off.
Sure. So I have another set of slides. I had actually put together something more along the lines of just sensing for precision viticulture, kind of a more general talk, but I actually have one that we just used with Adelaide, Dave, that I could pull up. That's a short 5-minute kind of
Whatever
thing.
you'd like to do.
I think, what aligns best with you, Kaan? What do you think? Are you doing research? Or are you talking more about the mechanization just more generally? Kaan, I think you're muted. I just want to make sure we're kind of, I think we were.
Mason, I think it would be great to talk about what you're doing.
Sure. Let me just grab that. Let me grab that talk real quick. All right, here we go. All right, let me share my screen real well, if it's going to let me. There we go. And just turning this one off. Okay. Despite using this every day, I still am not that good at it. There we go. All right, let me know if you guys can now see. Not yet. Okay. Is this the primary one? I think this is what I think this should be getting it. Yeah, you guys see that?
Yep.
Okay, we just did a slide switch. So get my head in that space. Okay, here we go. So I'm going to talk a little bit, very briefly, about what my current research is. And again, like Dave said, I'm pretty new to the grapevine world. I've done some work actually. If you want to talk about the insides of grape leaves and how all of the physics of the gas moves around and all that, I could tell you a good amount about that, or the vascular systems. But as far as viticulture goes, I'm ramping up to speed. So obviously Kaan and others are becoming great resources, but I'm learning a lot, and we've already started doing a decent amount of research in vineyards. One of the first projects that we're working on and started doing has to do with AI-enabled sensing in vineyards, and specifically trying to develop a kit that could be used as a platform more generally, so that it's maybe not so specific to one problem, but that it's set up to address numerous problems going forward in the future. So what we've done here is we started off last September, I believe it was, right around harvest, working with some folks at Gallo. We went out, I just started, we had about a week left before they were going to remove the grapes, and so we really need some data before the grapes are gone. So we took some of the ATVs. We built a small system that could capture imagery at a pretty high frame rate, geolocate that, so just tag it in space at a sub-meter resolution, and have some little controls and data processing and saving that would go on. From that, we've actually started a second version of this sensing kit, which we're starting to try to build now, and we've deployed on a robot, which you can see in the second figure. So the middle figure is showing a schematic of what the sensing kit is. And the long story short is that we're now collecting standard camera, RGB, red, green, blue images, just like your standard pictures you would get. But we've also got depth imagery and also infrared imagery all within this small kit. And we can build this one for about $1,500 per kit. And it can do a lot. It can do a lot of AI on board. It can store a lot of the data. It has a battery pack, or we'll be hardwiring it into some systems. And the idea is that we're hoping to be able to have it modular enough where you can go and put these on tractors, existing tractors or ATVs. So the goal is to be able to integrate into existing operations and to piggyback on, just grab data during the time for you, during the times when you're already in the vineyard, right? So one of the things we're planning on trying to do is get out and go, say for dusting or sulfuring. That's happening pretty regularly, at least with some of the folks we're collaborating with, on a 7 to 10 day basis. So the idea is you're already there. Can we build a kit that can just be put on and go ahead and just start collecting data at the same time? And so, can't remember how much of this I show here. Yeah, great. So we're doing some work where we've got a robot roving around collecting the baseline data to build some of these models outside of RMI. Once we're all back in action, feel free to come up, and it's going about once every week. It's going through our international vineyard plot, and we're trying to monitor phenology in addition to making longer term projections on yield using that phenological information up front, and also just a lot of imagery data along with weather data and so on into a deep learning model, so kind of a machine learning type model. Here's some images from, we're not using VSP. These are out in Lodi, pretty messy, kind of hard to see the grapes. So we've started building models that actually can predict the grapes. We have some better predictions than this now. Just wanted to give you an idea for what they look like. And so the next step going forward, we'll be starting, as I mentioned, is putting these, about 3 to 5 of these kits on tractors. This will probably, for now, we've got some folks at Gallo interested in this, but we know that only represents a small portion of the type of growing that happens. So we really need to, we're starting some conversations with folks in the Napa, Sonoma, and other types of regions that might be interested as well, because we know that management varies widely. So that's what we'd like to, I'd really like for folks to reach out to talk about this type of thing as well. So the idea is to be able to use these models to go against some ground truth yield data. And the nice thing about some of the people we're working with is that they have a lot of ground truth data on yield, right? So we need a lot of that to train these sorts of models. So I'd like to learn more about where those opportunities are at in other types of vineyards as well. And then the last piece, so I'll just maybe another 1 minute, 2 minutes. I think we didn't want to go too long. It's a project I'm doing with Dave Block. And we are working on trying to understand at the single vine level, more along the lines of how much water is a vine using, and whether we can come up with low cost sensing systems that could be put onto many different vines to track that more precisely and based more on first principles, or that plus some empirical models as well. So we've got a number of lysimeters outside of RMI where we're doing some work on this, when the student who's leading this name is Matt Jenkins. And so we're going into another season of data, and it's looking like we're going to be flooded with some data very soon. So I'm also doing a little bit, I'm in bio and ag engineering, so I'm not going to go into details on this, but these, I think there's relevance for breeding operations and other types of operations in terms of grapevine. I've got a student who's working on lettuce related, vertical farming of lettuce, and doing automated monitoring in 2 dimensions of growth, and trying to make predictions of the biomass over time. On every hour, have estimates of biomass for every single plant, so we can then try to build relative growth rate curves out and make projections to when we'll anticipate harvest and where there might be lower weak points, and ultimately feed back in with some precision controls. And then also doing a little bit of work with almonds, but again, all of these methods kind of overlap, and I think there's a lot of potential for grapes as well. So that's kind of an overview of what I've been doing the last 8 months or so in the lab. I'm gonna stop sharing my screen here and hand it over. I think you want to go ahead and have Kaan give his presentation as well, and then open it.
Kaan give an overview of what he's working on in the area of mechanization, and then we can open it up for questions. Go ahead, Kaan. You're muted, just so you know.
It is my habit to be muted, I think. Although I do miss the online interviews we did. Let me see. Okay. All right, here's my screen. All right. So Mason and I chatted a little bit. So I'll go through what's possible in mechanically managed vineyards. Then I'll show a brief introduction to some of the sensing work in the mechanically managed vineyard that we have at Oakville station. So I think some of you guys have heard me talk about these things previously, but of course, we're under quite a bit of pressure from economic forces to drive mechanization in vineyards. And the number one thing is the timeliness of cultural practices. We have a lot of consolidation in the industry. Vineyard sizes are getting larger, so the timeliness of doing the cultural practices of essence now. And of course, we're lacking a willing labor force. Vineyards are a rural industry. We are not close to we're not in close proximity to population centers. So that's affecting the quality of life, socioeconomic factors. So a lot of people do not want to work in vineyards. So we have this evolution towards spatio-temporal management of vineyards, like Mason said. Mason showed the final approach, but I'll go through what we are facing right now. So presently, we're managing everything uniformly. Both the soils and the vineyards are managed uniformly. We do bulk or composite vine and soil sampling. In the interim, there's a zonal vineyard and soil management. So this would include stratified random sampling within a zone. But as we improve our, site-specific vineyard and soil management, this will require fine grid sampling, sensing, or scanning. We can do a lot of things mechanically in the vineyard. So I have divided our commodities as wine, raisin, and table. We also have concentrate commodities. We can do everything that we want mechanically, but the easiest thing to mechanize are, of course, harvesting in wine grapes. 90% of our acreage in California, probably more than that, this year will be mechanically harvested. When it comes to pruning, about 65% of the wine grape acreage will be pre-pruned by a machine, then followed up by hand. 12% is box hedge, meaning that these single high wire trellises will be pruned in one pass. When it comes to canopy management, hedging, this has always been done mechanically. Leaf removal, about 45% of it is done mechanically. Some people will do shoot removal, and some people will also do fruit removal mechanically, although there's not a whole lot of economic incentive for people to remove a crop. We have a shift towards non-positioned conduction systems in California due to climate change, and this is going to affect how we mechanize things as we move forward. We're taking vertically shoot position trellises, we're opening them up and letting them sprawl. But as you change, row directions, this also has an implication for quality in the long term. So I tried to summarize some of the trellises that we see. Based on our survey in 2016, we have 17 different types of trellises in California, but they can be all broken down into a form of these trellises that I have summarized here, such as the modified California sprawl, vertically shoot position system, quadrilateral system, single high wire or head trained. Then here are some of the practices: pre-pruning, final pruning, shoot thinning, leaf removal, cluster removal, trunk suckering, and harvest. This is their adaptability to mechanical management. Of course, head trained vines, very difficult to mechanize these, including harvest. Two things stand out, such as the high quad trellis or the single high wire. These are very easy to mechanize. In fact, they were developed for this purpose. These are the ones that are in most use for high efficiency mechanical production. Single high wire system is 62 to 66 inches tall. It's non-shoot position, about 35% exposed leaf area. Currently, we can get into production in about 18 months, about 11 to 24 tons to the acre in 7x10 spacing. High quads are about 68 inches tall. These are divided canopy, 36 to 48 inch cross arm on top. These are about 70% exposed leaf area. So we see about 14 to 32 tons to the acre in a 6x11 spacing. How they look is fairly straightforward. The one on the left is a single high wire. You usually have a stake that's beveled, and then the cordon is about 5 feet 8 inches above the ground. It's as it is. You see, it's very straightforward, quite cheap to put in. High quad is actually two single high wires separated about 24 inches with a catch wire up on top. So these are very simple trellises, not a whole lot of wires to move, mess with. You can just zip through and prune these and apply many practices. The vineyard at Oakville, it was put in at like 2016. We received the first crop in 2018. It's a single high wire system. We never really did anything by hand other than grafting and tying these up. After that, it has been managed mechanically, starting in the second leaf. The spacing is quite tight. It's 1.5 meters by 2 meters, 5 foot by 6 feet 4 inches. It's a Cabernet vineyard on a 3309. So this vineyard settled at roughly 8.5 tons to the acre, and our cost here at this site is roughly about 22 cents a vine for labor operations cost, compared to our $1.20 in our modified VSPs. So everything is done mechanically, as I mentioned. This is pruned to a hedge, 4-inch hedge, a 10-centimeter hedge. This is done in one final pass. No other pruning is done. The bearing height is based on previous year's crop load. So essentially 8 pounds of fruit per pound of dormant pruning here. And we do remove shoots to achieve a vine balance. This is applied at a 6 to 8 inch stage with this implement. Main goal is to control cropping in this case, because otherwise, we can achieve up to 14 tons at this site. There's no need here for our clientele. So we remove the shoots. Of course, at the site, we did some sensing. Our sensing was looking at water status variability. And then this was achieved by first laying a grid and then measuring the plant water status, then linking it to a sensor signal and then to a berry primary metabolism. I'm not going to bore you too much with the sensing. This is something commercially available off the shelf. This is electromagnetic induction sensing. We can sense soil electrical conductivity down to 1.5 meters divided by in half. And then it's analyzed in regular statistical packages. And as you can see, the vineyard divides into 2 management zones, high water stress, low water stress, and this is consistent through the years. We get the same response from the vineyard, even though we might have contrasting precipitation patterns 70% of the time. And then the soil EC, soil electrical conductivity, divides pretty much the same. And they relate to each other quite well. And when we look at yield components, although there's a whole lot of interest in dividing these things, these small differences in plant water status do not necessarily affect yield. And we get the same yield on both sides. However, what it affects is the quality in the vineyard. We can, see the modulation anthocyanins and flavanols. So how this work is developing in the future, we're going to look at probably a more selective harvest and variable irrigation delivery at this site. We already cut down the number of samples we can take down to 2 in each management zone by installing a TDR sensor. So this is in near real time. And this can be monitored by wireless mesh networks as we move forward. So I'll stop here and we'll go.
Okay, I think you can stop sharing your screen. Thanks, Kaan.
How do I do that? Oh,
I already did it for you.
Oh,
It's a service I provide. So at this point, if people have questions, please, you can type them into chat or just raise your hand electronically or just start talking. But while we're waiting for people to do that, maybe Mason, would you be able to talk a little bit about what you think are the biggest opportunities for emerging artificial intelligence technology in vineyards?
Sure, I can certainly talk a bit about that. And Kaan, please provide some feedback, because I think you definitely have a lot more practical experience and a lot of experience in general with this. So, so where I came from, I think there's the way I think of what's happening in AI right now from other fields. I think one of the big things about agriculture is that right now we just are kind of using AI from other industries, right? So any of the technology that's generally developed. So let's say, for example, computer vision technologies oftentimes are developed by who we're all used to hearing about, Googles and your Facebooks and so on. And we end up kind of with technological byproducts of those industries, which is great because we kind of get them at free of charge. But oftentimes they aren't designed specifically for our tasks. And so I think one of the things I'm particularly excited about is bringing together of, I think, mechanistic types of models, just meaning things that are already being used, whether that has to do with predicting phenology from growing degree days, frost days, and so on, and bringing that information into sensors and AI types of systems. So the kind of convergence of what's been done and what's being used currently and the practical knowledge that's already been gathered over the last thousands of years, and especially 100 years, in terms of viticulture, and bringing that in and connecting that with some of the latest methods. And so there's a pretty big effort on campus that we're pushing for to start doing that sort of thing. And right now, not a lot of that is being done. That's not to say there isn't some being done, certainly, but I think we need to really have that, bring in more computer scientists, more engineers, and get them to really start thinking about viticulture and agriculture more generally. And so I know this is kind of like a very broad answer, but I think that's something that I am particularly excited about. I don't know if Kaan, do you have anything you wanted to add to that in terms of your experience? I know you've tried out a lot of these different tools.
Yeah, we tried out a lot of the tools. I mean, the biggest opportunity and the biggest lack of service to the industry right now is a reliable way to like estimate yield. I mean, yield is paramount. I mean, everyone gets paid by the ton, so to have an accurate yield is paramount. So I think that is still the biggest opportunity. But we worked on it for 2.5. We didn't get very far with previous approaches.
Yeah, so I would say that one of the big challenges in terms of developing something like yield prediction and yield forecasting, especially the ground truth, so to speak, which is still shaky sometimes, is weighing the berries, right? So something like a yield monitor, and obviously, the real gold standard would be to weigh every cluster yourself on a very precise scale, and that's done often in the research setting, but it becomes completely impractical as you move to any sort of commercial or even small scale commercial operation, right? So then it moves into the mechanization. You say, okay, well, we'll put load cells, which are just scales, on these harvesters, and then you can start weighing them as they're moving across the conveyor belts and being dumped into bins. So we need more ground truth data. I think that's one of the big challenges. So to zoom way out, what do I mean by that? So there's, in the world of machine learning, what it really means almost all the time when you hear this is that you are training a model to predict something that that you're calling true, right? So if what we're trying to do is show a model an image and say, tell me how many pounds of grapes are in this image, you need to actually know how many pounds of grapes are in the image, right? and to do that, we really need to weigh that. And these models depend on the more data you give them, the better they do. So the challenge that we face is that there's so much variability across the types of vineyards and the types of conditions, whether that's cultivar specific, management specific, or environment specific, that we need better ways of really bringing all of those pieces together. And we need lots of ground truth data from those different locations. And so I think that's our first big challenge, is just trying to be smart about sampling across a representative sample of, let's say we're trying to do yield of mass, right? We just need mass. We need lots of images that correspond with it. And that's assuming that the images can actually predict the mass too, which I know Kaan would say, maybe. I'm not sure. Yeah.
And part of it probably has to do with your algorithm, right? There's all kinds of approaches you could take. Some of them might work better than others. Some might be more general than others. Whether you're trying to count the actual berries, you're trying to count the cluster and have an average cluster weight. You're trying to see, partial occlusion where you as a person can see there's 3 or 4 clusters there, but some algorithm has to do that. And some of these algorithms are going to work better than others and more generally than others, which I think is part of the challenge, right?
Okay, before the engineers take over.
Thank you, Anita.
Practical question, Kaan. So don't talk about algorithms, okay? So you showed an example of the no-touch vineyard, and that's obviously the ultimate, and it was planted to be that way. But say you have somebody that's interested in mechanization due to labor shortage, etc., but it wasn't specifically planted to be mechanized.
Right.
What are the common practices that you can mechanize in such a vineyard?
Well, we work with folks in the foothills that were like head trained vineyards. So it's quite straightforward, actually. We end up putting end posts at the end of the rows and then just trellis them because they already had stakes. So the easiest thing to mechanize in this case was harvest. So they were able to, harvest these mechanically. And the following season, once the new cordons were being established, they were able to do the leaf removal.
Okay.
So if you just want to dip your foot in it, the easiest things to mechanize are number 1, harvest, and number 2, leaf removal.
Okay, that makes sense.
Yeah.
And quick follow-up question. So say you're in a position where you're planting a new vineyard now.
Yeah.
And you want to be able to mechanize that, right?
Yeah.
There's a huge cost involved in that as well. So what's the point of breaking even? Because yes, you have a huge capital investment in equipment, etc., versus you are saving labor.
I don't necessarily look at it as like saving labor per se. You still have labor needs. You're just using a different type of labor. But the break-even point is 18 months in mechanically managed vineyards. And other than the very small area of this valley that I'm in, I don't know any vineyards that are not going in that are not going to be mechanized. So everything is going in for mechanization right now. So, but return on investment based on our latest papers about 18 months.
Dave, you want to ask a question or can I be on a roll?
Go ahead.
Mason, before you go to sleep. So what kind of sensors are generally available for people that they can use for precision viticulture?
Right. And I think that's a good question. And again, this is one I'll talk about the general idea for a minute, and then Kaan, please chime in, because I know you've used a lot of sensors as well and tested them, and you know what works and what doesn't so far. I had a few slides on this, but just generally speaking, I think before I switch my slide deck, the general way I think about this is, you all know probably better than I do. You've probably been approached by a number of people trying to sell you a sensor. But a lot of what we're interested in, I think first we've got yield, right? So we've already talked a decent amount about yield. So there's yield monitoring on the actual mechanical harvesting. And then there's image-based monitoring. So a lot of these a lot of systems work somewhere in the electromagnetic range. What do I mean by that? Light, basically, right? So maybe that's visible light, maybe that's infrared light, maybe that's microwave, maybe it's some form of light-based energy. And so what that means is a lot of them are either like cameras that see specific types of light, or they might be some other type of imaging system. Other than that, so we have things like people might be trying to detect quality as well, right? Kaan, I think you've worked some on some of the in-field chemistry sensing from like spectrometers and this sort of thing. Have you done much with like anthocyanin detection? You might have like a handheld spectrometer. Have you used those before?
Sensors, they can be on a mobile platform, or they're stationary.
Right.
And the stationary ones are the ones that the growers are most marketed right now in the form of soil moisture sensors or sap flow sensors, that kind of stationary kind of sensing. So soil moisture sensors work. They can be like real TDRs or like dielectric sensors, etc. But how many of these do you need per acre? So that's like another opportunity of investment or investigation. On the mobile platform, we looked at canopy reflectance sensors, the active sensors such as the ACS 300s, the crop circles. So you can calculate NDVI with these, etc. However, you still need some sort of data processing capability, which most growers are not willing to take on. On the harvester, we looked at the fluorescence monitors, which is, you can get some sort of an anthocyanin proxy. They do work as well. They get you in the ballpark. So in an industrial setting, if you can, pick 80% of the color of a Cabernet Vineyard, it's pretty good for a differential harvest. For remote sensing, there's lots of services available. However, a lot of them will not provide you the raw data. On the raw data end, we work with series imaging, which were able to give us thermographic images at sub-meter level. But again, you need some sort of data processing capability.
Right.
Everything works until someone hires a PhD student to work on it. But the commercialization is we still have a way to go, in my opinion.
I think one thing I wanted to add on to that I think is an important point is oftentimes I feel like there's a big gap between the precision of the sensor and the precision of the management action you can take. And so I think that's always an important question when you're looking at saying, okay, what am I looking at? If I'm looking at, I want to know water stress, right? In a particular, I want a sensor that measures the water content. First of all, you have to say, well, how related is that to the thing that I'm actually interested in, right? So the thing you might actually be interested in is some effect on quality. Or maybe you're interested in yield. So the first thing you have to say is what can I actually do if I had the ability to measure water stress at the vine level? Could I do anything about water stress at the vine level? And this gets at what Kaan was talking about earlier, that right now there might not be a solution for actually watering at the vine level, right? There might. So when someone comes and says, I can get foot level accuracy of NDVI, I'm always a little skeptical because I don't know exactly what I would do with NDVI directly. I have to assume it's related to something I'm interested in, right? Which might be yield or maybe I want to thin based on it, but there's an action I have to take that isn't just NDVI. And then I think there's also a important question about even if I did know that and I knew that it meant something, what could I go in, how precisely could I go in and thin, or could I go in and actually harvest and measure the yield, the effect of that NDVI on yield?
Well, that leads into, I was going to ask, okay, so when does the data become actionable? But you sort of spoke about that a little bit. I don't know if you have anything else to add on it. What do you do with the data? What does it mean? When does it mean something? When can you actually apply it in your vineyard?
So Mason, while you're thinking about the answer to that, I just want to encourage everybody to, if you have questions, please go ahead and ask them. We have lots of questions, but you can raise your hand or just write them into chat and we can read them.
And they can be really specific too. I may not know the specific answers and Kaan may not, but we might. They can be, about a specific technology or a specific management practice.
Go ahead, Mason.
Sure. So the question was about management action, right? So how can you turn these kind of sensors into management actions? Well, I was just kind of blabbing about that for a second. I don't know if Kaan, do you want to say a little bit about that? I know you've talked about it in your presentation as well.
The plants grow together in communities, and the population and the means of these plants are going to be affected by the media in which they're growing in. So if you take a 10-acre vineyard, usually you will have 2 management zones. In the case of water status, in our experience, these last 5 years when we studied this very closely, more often than not, the difference between the 2 sides was between 6 to 10 millimeters of water difference over the course of the season. So 6 to 10 millimeters of water difference across the course of the season might not seem as much. However, that's still a half an inch of quarter to a half an inch of water. So if you're trying to, take action against this thing, the idea is not to, reduce the application by, 6 to 10 millimeters on the side that's performing well. It's to increase the production on the side that's producing less or not as desirable. So that's where the action comes into play. So designing these systems and being able to deliver this amount specifically, whether it's a single vine or like a whole management zone, it's going to take a serious amount of engineering. So therein lies the challenges. We can identify the differences, decide that they're manageable, but then that's where the real innovation will have to come in to be able to deliver these things very specifically. On the other end of the spectrum, when you look at making decisions based on NDVI sensing, there's a lot to be desired for. Because most growers will not remove shoots because they're getting paid by the tons. When you look at NDVI maps, convert it to a pruning map, and then drive a crop load map from it. In the end, again, the crop load does not necessarily vary spatially. The variation is coming from soil texture, from water status. So I don't know if that's something that we will actually delve into in the future.
Okay, so I was going to make a comment as a non-viticulturist and a non-engineer. So as I know it and understand from what you're saying, and you can both chip in and correct me, is that you get sensors for yield, and obviously they don't work all that well because we're all still investigating yield. Everybody I know is interested in yield. You get sensor for soil moisture, would work, but the question is how many do you need and what action do you take with that data? What does that relate to? Then we have the kind of remote sensing where you can look at difference in vigor that gives you an idea of variability within a vineyard, and which you have to physically go and correlate with. Is there a difference in ripening? Is there a difference in yield? Is there soil differences there? And many times there is a relationship, but that's basically the groundwork you have to do to give meaning to that sensing data. Is that correct?
That's a great summary.
Yeah.
Okay.
I'm glad Anita's here. Yeah, this is, yeah. No, I mean, that's
very good with 101 classes.
No, it's great. I mean, that's exactly right. There's always the question of what does it mean? Like, what does this mean for me? And can I use this in a way that I can derive some value, right? And I think you're right. That's like, often it's site specific, like NDVI in one location for the exact same NDVI somewhere else under maybe a different trellising system where you've got more leaves stacked on each other or whatever it might be could be related to yield loosely very differently, or whatever that is, vigor very differently. So these measures are often, especially when you see the word, so I'm always like, anytime I see the word index after something, I immediately become skeptical, and I say, like, what do you mean? Because people think if it's a physical unit, they're like, here's how many pounds. I'm like, oh, I get that, I can go weigh it. But whenever you hear index, and that's not to mean it isn't useful. That's just to say that, like, I'm always start off skeptical when I hear the word index, because usually it's derived from a number of physical things originally that have then been correlated with something enough times where someone thinks it's related enough to make a decision on it. Yeah.
Well, and that action is going from that measurement to that action. I think one or both of you have already mentioned this. That's really the hard part. You can figure out how to take the action. You can figure out how to measure something, but knowing how to see what NDVI is or any other sensor is, and knowing what action take is the difficult part, at least one of the difficult parts. And what that means is you generally have to have a physical or a mathematical model or something to take whatever the reading is that you get and decide what you're going to do. So take a plant stress reading or some temperature, humidity reading, and use that to decide how much water am I going to put on this one vine or this one management zone or whatever it is. And, in addition to Kaan and Mason, a couple of our new faculty members, Megan Bartlett and Beth Forrestal, I think maybe Beth is on the line, are working on either experimentally or mathematically trying to understand the relationship between the things that you can measure and the things that you should be doing to get the outcome that you want.
So I want to add on to that, Dave. I think something I'm particularly excited about. So you asked the question earlier, Anita, like maybe Dave did, what is the future of AI? What can AI actually do other than generate some hype? And so I think there's something cool that's already being done. So it's done on all your cell phones. And so it's called collaborative learning. Okay. And this means learning from the machines are learning, right? So the idea is that there's generally a model about, let's say, how I relate I talked about regular images and IR images. Let's say you have those, and let's say we've got some of these, say you've got some cheap sensing kits, or even if you just have your phone and you're constantly doing things, and there's a base model that your phone kind of starts off with, let's say Face ID or something along those lines. And so it's learning, it has a base model of what a face looks like anyway, just generally speaking. And so what you want to, in this case, but it needs to be specific to your face to actually securely allow you to unlock your phone specific. And so it'll start with a base model, but then there will be, based on your local sensors on your phone, it will fine tune a model to your specific face in this case, or condition. So I think the idea of having, if you can get low cost enough sensors out that are kind of moving around and constantly monitoring Vineyard, I think by just piggybacking on your existing operation. So you don't have to do anything different. It should be easily integratable. You strap them on and they're just constantly doing this. Then I think through that process of like starting with the basic foundations of, okay, this is what a plant looks like. These parts are leaves, these parts are grapes. Then you can start fine tuning those models specifically to your location so that you can get past that like issue of saying, well, there's a lot of big differences between my management techniques, my specific grapes, and everything else to make more generalizable types of models. And so that's kind of, I think, a longer term goal is if you can get a lot of sensors out there, have them start learning, and then they become more personalized or customized to your specific locations, they can get better and better.
Yeah, but so I'm thinking here, like you have Mason Kaan. So both is, you have precision viticulture on the one side, and you have mechanization on the other side. And there's an overlap there, but there's also a little bit of a difference in focus. But precision viticulture really is focusing on dialing in per vine. Mechanization generally works more on the collective, right? So, and basically the overlap is whatever your focus is, you still want the best quality that you are able to get, right? So for me, that's very interesting about precision viticulture going per vine. The idea is to get the best per vine. Mechanization in general, I see, yes, there's a lot of increase in efficiency, but still with the idea of at the very least not impacting quality, but if at all able, actually improving the quality if possible, correct? So it leads me to think, right, we know precision viticulture, but nobody's thinking if you go per vine that you're going to damage a vine. But are there there is sometimes this perception that mechanization can actually damage a vine or even impact your grape quality negatively?
Yeah, I mean, that's one of the most common questions we get, especially since I moved to the North Coast. So talking to like media, that's one of the first questions that we get, like does it hurt the vines? And I know the plants are alive, but they don't have feelings yet, but they have somewhat of a give. So if the trellises are set up correctly and sturdy enough, there's little to no damage to the plant in mechanically managed vineyards. Furthermore, in all of our cases, we have seen the quality improve. Chemically improve, meaning that we were able to improve upon the anthocyanin and tannin properties of the fruit that we were harvesting. But of course, I have exclusively worked with red wine grapes the last 9 years. So I think the hesitation from most folks has been that they have not seen this, or there has not been an economic necessity from the general population to adopt these practices so far. So it's new, but we all adapt. We're all teaching from home or whatever, so we're able to adapt to new realities very quickly.
So on that note, on the note of adaptation, we have about 5 minutes left. Karen Block is going to let you know what the next our next office hours with Dave and Anita is going to be about. So I'll turn it over to her.
On May 26th, which is 1 week from today, we'll have Kaan, and Kaan will also bring Larry Bettiga, who is one of the farm advisors down in Monterey and Santa Cruz counties. And they're going to discuss the finer points of canopy and crop load management in the challenging market. More specifically, you're going to look at options for new trellis types for growers, considering mechanization, and how to convert existing vineyards to systems that are more amenable to mechanization. And in addition, they're also going to discuss some do's and don'ts if you're considering mothballing your vineyards for this season.
Great. So yeah, thank you, Karen. So going to be another interesting show next week. Again, we have about 5 minutes left. If people have questions that they'd like to ask, go ahead and ask them. Otherwise, we won't run out of questions, I'm sure.
No.
So Mason, maybe we can talk about irrigation a little bit, because you mentioned that briefly in what you said, and I'm wondering where you see your technology used for irrigation management in terms of artificial intelligence and deep learning. Where do you see that research going?
This is, I've thought some about this. So I think there's a few pieces. There's the stuff that, again, Dave and I are working on together. And then I think there's another piece too, which maybe is something I've been thinking about lately, which is how, if we are constantly monitoring, I guess there's constantly the use of ATVs, right? People are, depending on the size of your vineyard, but you're wanting to go out and keep track, and maybe from veraison through harvest, I guess I'm told that a lot of what's happening is you're looking for either leaks in your irrigation or you're going out and doing a lot of consideration because that's the hot period of the growing season, right? And so I do wonder, I think there's some opportunities if there are already pieces that are moving around and they're kind of, maybe they're hard to spot. There's opportunities for using thermal types of imagery, right? And it doesn't have to, there is low cost thermal. But then it's not very spatially resolved, meaning like you don't get a great high quality picture. but you can definitely spot hot and cold areas. So you just point it at the ground. If you have a low-cost thermal image, you could probably, I think there's a good opportunity for spotting leaks pretty easily in a relatively automated sort of way. Obviously, you have to go in and still fix it. But I think on the other hand, with respect to the precision irrigation side, I think it's like Kaan said, you have to start off and you have to start thinking, okay, if I could manage, what's the first thing I could do? And that's maybe managing at a slightly smaller spatial scale. So breaking it down into sub-block level, but maybe management zones, right? So first you need some information about where the vines are or the regions are that are more and less water stressed, or where the irrigation is more or less needed, and then start breaking it apart into smaller zones and kind of moving forward from there. I think the vine level sensing, we need vine level irrigation at that point. So I think that's still a little ways off, but I think that potentially could be the future if it's cheap enough.
So I wonder if you could also, I mean, so we hit all the what we see as most of the major issues for viticulture in California. We talked about labor shortages, we talked about water issues, and maybe the third one is pests and pest management. And so I was wondering whether maybe you could talk about whether you could use the imaging and image analysis or other methods to detect both diseased plants and also vectors in the field, and where that might go.
Yeah, I think there's been a lot of work. There has been a good amount of work done, especially on this research side for disease detection. A lot of it centers around the use of hyperspectral imaging, which, for better or worse, it's like a camera that can see very specifically tell you what color it sees, right? So this is 402 nanometers of there's this much at 402 and this much at 405. And so all that boils down to, though, in my mind, they're pretty expensive cameras. I mean, we're talking tens of thousands of dollars. So the trick is getting from there, which is where the research is at, to something that is more affordable, because there are so many different possible diseases. And they symptomatically express themselves in different ways. And oftentimes once they're symptomatic, it's too late anyway. So the question is, can the focus is on early detection, prior to symptom, like asymptomatic or pre-symptomatic detection, and then doing that at a low cost. And so I don't know that we're there just yet, but I think it's certainly an opportunity for a lot of research. Yeah.
So Dave, I know we're basically out of time, but there was a really good question that came in. I wondered if we could quickly ask it. And those that do have the time to hang around for another couple of minutes, I think they would be interested in hearing the answer as well. So the question was, I'm curious about the practicality of mechanical pruning in an area focused on viticulture precision like Napa Valley. Is it feasible at this point to consistently prune a vine mechanically to, say, a 2-bud spur? Or is the accuracy of mechanical pruning more akin to a hedger and highly subject to driver variability?
I was muted. Yeah, pruners are not robotic pruners, but yes, it's possible to prune them down to a 2-inch spur. However, it does not clean up in between the spurs. So the distance between shoots is still maintained from the previous season. However, what the pruners will do is they'll get the hangers from underneath the cordon. So if you can imagine the number of buds you retain on a plant on a continuum, what mechanical pruning does is to simulate hand pruning. How you achieve the correct shoot density is by mechanical shoot removal. But I do not foresee robotic pruning going back to 2-bud spur pruning. That's not how the industry is evolving. And furthermore, there's lack of investment in these companies to derive this type of development at the moment. So, but the way they're set up now, they work extremely well. So I'll leave it at that.
Okay. Thank you. So Dave, are you going to say bye-bye?
I was going to let you, but I'll do it if you'd like me to. So I want to thank our speakers. I'd like to thank Mason and Kaan for coming in today and talking to you about vineyard automation and mechanization. And thank all of you for attending. Again, next week, going to hear about canopy management and also how to prepare your vineyards if you don't plan to use them, if you plan to mothball them for some amount of time. You'll hear that next week from Kaan and from Larry Bediga. So with that, I hope everybody has a great Memorial Day weekend, and we'll see you next Tuesday. Thank you.
Thank you, and goodbye.